morning everyone. I am M.TECH, Assistant Professor in M.TECH University, Madhya Pradesh. In this video, we learn about asymptotic analysis and asymptotic notations. So let's see what is the analysis regarding algorithms. So following topics are to be covered in this video, which include asymptotic analysis, worst case, average case, and best case of the algorithm with example. Asymptotic notations, comparison between complexity of the sorting technique and also growth rate of the complexity. So let's see what is the asymptotic analysis. Asymptotic analysis refers to defining the mathematical foundation framing of its runtime performance. So here time complexity is declared by the asymptotic analysis and notations, and asymptotic analysis refers to defining the mathematical foundation and framing of its runtime performance. Asymptotic analysis refers to computing the running time complexity of any operation in the mathematical unit of the computations, and it also conclude best case. Okay, by using the asymptotic analysis, very well conclude the best case, average case, and worst case. So, asymptotic analysis, it can be classified in three categories. First one is worst case, second one is average case, third one is best case. This case is regarding the time complexity of an algorithm. So, next we will discuss what do you mean by worst case. Here, there are three types of asymptotic analysis: worst case, average case, and best case. So let's see first worst case. Worst case means is the longest time performance required for an algorithm. In this, an algorithm requires longest time or maximum time for an executions or solving the particular problem, and also declare the result. I will explain through the example in my next slide. Next one is the average case. Average case means is the particular algorithm required average time, not short or not longest time. That means not minimum or maximum time. It lies between best and worst case. That is average time of that particular algorithm which is declared by the average case. So I think it is clear. Average case means your item is declared between the best and worst case. Next one is the best case. So best case is the particular algorithm required the minimum time for the solving the particular algorithm or problem and declare the result. I have also explained in the next slide with an example all three cases: worst case, average case, and best case. So the concept of worst case means longest time, the required average time, and worst case means best case means the required shortest time for the execution of the algorithm. So here we explain worst case, average case, and best case. So it is just the concept for the algorithm analysis. I think it is clear. Next, explain with the example. This is the example of best case efficiency. So let's take first example. Here we given input is 25, 31, 42, 71 and 105, and you have to find out 25. So first we check 25 present in the list or not. We have to use linear array, linear search. So we have to search the element one by one linearly. So first we have to check 25 present in the list. Search is successful. 25 also present is in the list. So only required single comparison. Require minimum time, only one comparison is there. So this is the best case efficiency. Best case already denoted by 1 available in the first position of the list. Here we see the best case efficiency, how we can find out. So if we want to search the element which is present at the last of the element or not present in the list, then such case are called the worst case. If we want to search 105 in the list, this is the linear list. Suppose the given input is 25, 31, 42, 71, 105 and you have to find out 105, this element in the list and search element in the linear list. So we compare with 25, not found. So after that we compare 31, not found. So we compare each and every element in the list up to the last element. So we have to find out 105 at the last location of the list, which require more time, longest or maximum time. So how many comparison are done? So this is require 1, 2, 3, 4, 5. That means 5 number of element. That means n number of elements and number of comparison. So it is called the worst case. It requires maximum time to find out the element. Second case is if the element is not present in the list. Suppose we have to find out 1110. Again we start the comparison with the first element in the list. Again match 25, 31, 42, 71 again and again and again. At the last location element 105. So 1110 is not present in the list. So these two cases are present in the worst case efficiency. First case is when element is the last location of the list. And second case is that when the element are not present in the list. So this is the worst case. So this is the worst case efficiency. And time complexity is denoted by the n in this case and n number of comparison is done in the worst case efficiency. I think it is clear. So next of the average case efficiency. So in the average case efficiency, let the element is not present at the first, that means the best case, or the last, that means the worst case. That means the element not present in the best case and worst case, not the first position, not the last position. That means element present between them. So let it is present somewhere in the middle of the last list. So we calculate the probability of successful search means P lie between the 0 and 1, and if element not found in the list, then the probability of unsuccessful search find out the 1 minus P. Hope so you understood the best case, average case and worst case. Next topic is asymptotic notations. Following are the commonly used asymptotic notations. We calculate the asymptotic notations by using the running time complexity of the algorithm. There are only three asymptotic notation: big O, omega and theta. Big O denoted by the big O, omega denoted by the case and theta denoted by the theta. So let's see how it will be used. First one is big O notations. The big O before starting the big O notation, first we measure the worst case. So I already explained in my previous slide worst time complexity. That means your search item is present at the last location of the list. That means it requires the longest amount of time, maximum time to solve a particular problem. If your algorithm require worst case, that means your element present at the upper bound. So worst case denoted by the big O. big O notations. So let's see the diagram. Here, this is the given input and this is the time complexity, and we have to use two functions on there, fn and g of n. Fn denoted your input, given input, and gn denoted your indicate the time complexity or the worst case time complexity of the algorithm. This is called the upper bound, means required for solving the particular problem we required the maximum time to find out the result. I think it is clear. So next one is the omega. Omega notation. Omega notation is the formal way to express the lower bound of the algorithm. Lower bound means the best case. Your item is found at the first positions. So best case time complexity or the best amount of time an algorithm can possibly take to complete. So what do you mean by the best case? Best case means when such item is found at the first location in the list. So best case is denoted by the omega notation. So here f of n is the input, given input, and g of n is the best case of the mean. It indicates the lower bound, that means less time. So this indicates g of n indicate the less time. So omega f of n equals to g of n less than the f of n. So next one is the theta notation. Theta notation also expresses both the lower bound and the upper bound of an algorithm, that means running time of the algorithm, that means average time complexity, average case time complexity. So let's see the diagram. Here f of n is the given input and g1 of n is the lower bound, that means best case, and g2 and g of n, that is the upper bound. So average time between g1 g2, between like that. It is clear. In my next slide we will discuss some common asymptotic notation. Discuss some common asymptotic notation regarding time complexity. So following is the list of some common asymptotic notations. If your problem if your algorithm equation is constant value, so this is denoted by the big O. If your algorithm require logarithm equations, then time complexity is big O and log n. Okay? If there is a linear equation are present, that means we have to search start to end one by one. So it is denoted by the big O n. N is the number of elements present in the list. N log n basically used for the divide and conquer technique. So it is represented by big O n log n. If your equation is quadratic format, then time complexity is big O n square. And also the selection sort, bubble sort, insertion sort. This technique also help the time complexity O big O n square, because there are two elements. First element compare with second element and second element compare with next element and so on. If your algo present cubic equation, then time complexity is O and Q. And for the polynomial equations, time complexity is big O1 base n. And for the exponential equation, time complexity is big O n base 2. All are the common asymptotic notations of the worst case time complexity of the asymptotic notations. I think it is clear. Now here, comparison between complexity of the sorting techniques. Let's take the example of linear search. complexity. I have already explained the best case, average case, worst case. Best case means if item found at the beginning, that means only one comparison is done. Worst case means item found at the end of the list, that means n comparison done. Average case means item may be found or index 1, 2, n minus 1. So average number of comparison is n plus 1 divided by 2. Worst and average case complexity of common sorting algorithm are in this way. So here only we have to, in this slide we have only explained worst case, average case and best case. And we have to remember these values because this is the very important part of the data structure. So it must and how to remember this time complexity of the algorithm. The selection shows worst case time complexity is n square, average case is n square and best case is also n square. You have to just remember it, okay? And similar to merge sort, n log n, n log n, n log n, worst, average and best case, okay? And quick sort for the time complexity n square, average case, best case is n log n. Clear? This is the most important part of the data structure. So you have to remember this. Next. So here we display the final growth rate of the complexity. The minimum time complexity is denoted by the 1. This is the sequential approach, linear approach. If the algorithm require the largest amount of time for solving the particular algorithm, so it is denoted by the n factorial, okay? This is the largest time, maximum time, and it is denoted by the minimum time. The graph are follow in this way, sequential. So this is the way lower bound to upper bound. Always we remember the one thing, your project requires the minimum time for solve the particular problem or equation. This clear? Next. Thank you.